Okay, welcome back to part 2. We're on 7 through 11 now. Okay, so problems number 7 through 9 are absolute value inequalities. So 7 through 9, I'm going to abbreviate it as absolute value equations and inequalities. All right. And when teaching this, I usually remind you guys of ISS. So remember, we have I for isolate. And that means we want to get that absolute value bar alone. So we're going to say isolate the bar. We don't care what's happening in the inside, but on the outside, nothing should be added, subtracted, multiplied, or divided by that absolute value bar. The next step is after we isolate it, we're going to separate. And this means we're going to have two equations or two inequalities. And after we get that, we're going to solve. We can solve for our variables, all right? So remember ISS when doing these problems. So number 7, we have to solve and graph this inequality. So, I'm sorry, number 7 is not an inequality. I'm sorry, it's an equation. So we're just going to solve it. So we have -6 times the absolute value of 6 plus 3x equals -24. So what we're going to do is isolate it. Now, I cannot distribute this -6. Think about those bars as electric fences. So we want to move everything away from those bars. So in order to undo timesing -6, we're going to divide both sides by -6. And so we have the absolute value of 6 plus 3x is equal to 4. It's isolated. The bar is by itself. So from here, we can separate. So we can separate into two equations. So we have 6 plus 3x equals 4, and 6 plus 3x equals -4. Remember, absolute value is a distance. So now we're just going to solve now. So I'm solving for x, so I want to move everything away from the x. So the first thing I'm going to do is subtract the 6, and I have 3x is equal to -2. Divide both sides by 3, and we have x is equal to -2/3. Or let's try the next one. I'm going to subtract the 6 from both sides. I have 3x is equal to -10. Divide both sides by 3, and we have x is equal to -10/3. All right, so that's the first part of the problem. Well, that is solving absolute value equations. We have one more absolute value equation that we're going to look at solving. So number 8, we have 9 times the absolute value of x minus 4 equals 81. So remember, we need to isolate it. So what we're going to do is divide both sides by 9. And then we have the absolute value bar by itself. It's isolated. after here, we're going to separate it into two parts. We have x minus 4 is equal to 9, and we have x minus 4 equals negative 9. And now I'm just going to solve by adding 4. We have x is equal to 13. Add 4 to the other one, and we have x is equal to negative 5. So those are the absolute value equations. Now for inequalities, it's just a tad bit different. I'm going to add the rules for this so that we can tell whether it's an and statement or an or statement. Not for sure which one is going to be on your quiz, so I want to make sure I give you both. If you have a greater symbol, a greater than symbol, or a greater than or equal to symbol, this is an or statement. Okay, that's an or, because if you hear greater, you can pull that or out. And remember, for ors, we shade opposite directions. So just to recap. So for our and statements, we have less than. Can you hear the and in less than? And here, this is an and statement. Sorry, that's not right. And then our and statements, we shade together. Okay. So ors apart and together. Okay, so for number 9, we have the absolute value of 12 plus 4x is greater than 16. So this is telling me it is an or statement. So again, we're still going to follow the same rules as solving absolute value equations. Isolate, separate, and solve. So if I look at this one, this absolute value is by itself. I'm not adding, subtracting, multiplying, or dividing anything on the outside of this value, of this absolute value bar. So here, let's go separate. So I have 12 plus 4x is greater than 16, or I have 12 plus 4x is less than negative 16. When I switch the sign, I have to flip the sign. Don't forget that. So now I'm just going to solve it now. Subtracting 12 from both sides, we have 4x is greater than 4. Divide both sides by 4. We have x is greater than 1, or I'm still going to subtract the 12 from both sides. Now I have 4x is less than negative 28. Divide both sides by 4, and we have x is less than negative 7. I already know this is an or. So if I have negative 7 and positive 1, there's an open circle at both. So I'm going to shade to the left. I'm shading apart because it is an or statement. So this is number 9. Numbers 10 and 11, we are going to be translating absolute values. All right, so for 10 and 11, we're going to be translating them or moving absolute values. Okay, so what I want to first talk about is the absolute value function. All right, so f of x equals the absolute value of x. This is our parent function for absolute value. All right, so if I was to give you a mini graph, f of x equals the absolute value of x, it's just the v, whose vertex is at the origin 0, 0. Okay? Any other vertex is considered a translation, all right, or some form of transformation. So I want to tell you that, or help you remember, the vertex formula for an absolute value function. So the vertex formula is g of x is going to be equal to the absolute value of x minus h plus k. I know that may look confusing, but remember, it's not that challenging. So our job for number 10 is to translate the absolute value function f of x, which is the absolute value of x, to a new vertex of, let me make sure that this is our vertex, to vertex -5, -3. Okay, so I need to put this point into this vertex formula. So keep in mind that this is my h and this is my k, and all I'm going to do is plug it into that formula. So here we go. So my transformation is the absolute value of x minus, well, my h is -5, plus my k is -3. So all I'm going to do is clean this up a little bit. And we have the absolute value of x, double negatives makes that a +5 minus 3. So this is my new function. So if I was to graph this, this is telling me that I have to move my vertex from 0, 0, which is right there, to left 5, so that's 0, 0, 1, 2, 3, 4, 5, and down 3. Let me change the color. So this is my new vertex. So left 5, down 3. That is my new vertex. I moved it left 5, and then down 3. So that's that point, -5, -3. So that's number 10. And our last one, number 11. Let me go back to blue. Number 11, we're going to be doing we're going to horizontally stretch it by a factor of 3. So here is my function. F of x is equal to the absolute value of -2 plus x plus 5. All right, they tried to trick you up a little, but it's still in vertex formula for absolute value. They want us to horizontally stretch by a factor of 3. So remember, horizontal is always the opposite of what you think. So I'm only changing my x. So what that is I'm going to multiply my x by the reciprocal of 3. And we know reciprocal means just the flip. All right, so the flip of 3 is 1/3. So because it's horizontal, I am going to multiply my x only by that. So my function, so f of x becomes the absolute value of -2 plus I have to replace my x with 1/3 x minus 3. This is my transformation. And so I probably should change from f of x because f of x is our original function. So I am going to make that a g of x because anything that changes our original is a transformation. So if you could see, I replace my x with 1/3 x because it is a horizontal stretch. All right, so here's your video. Hopefully you wrote down all of the notes and you should do well on your quiz. I am going to upload a copy of the actual practice quiz so that you can refer to that as well. All right, guys, good luck. And if you have any questions, send me a message through Schoology. Chat with you guys later.